Hello, welcome to my video on the topic of electrical as it pertains to residential and commercial applications. My background is an electrical contractor in the state of Georgia. I received my electrical license as a master electrician contractor in 1997, and I have more than 25 years in the industry. Today, we're going to start the video about receptacles. This is a receptacle that you would commonly see in a wall, and most people are familiar with it. You want to plug your laptop in, you want to plug a light in. This is where you normally get 120 volts. There's 3 prongs on this particular receptacle. This is your ground in the center prong. This is your common, which is usually the larger prong. This is the hot, which is the shorter of the 2 prongs. And this is what makes up the electrical connection for a receptacle. Some receptacles do not have a ground, and that would be a 2-prong. But this is your common type, style, 3-prong receptacle. You can get these at Home Depot, Lowe's, or any other hardware store or electrical supply house. Let's talk about how it works. I drew a receptacle on the board, kind of looks like a snowman, but I think you'll get the idea. This is representing the receptacle, and this would be the ground. That's the center. This is representing the common, and this is representing the hot. When we apply wires to it, we apply it to the screws on the side and the green screw, which is ground. On most receptacles, the left side, which we'll say is the longer prong, is the common, so we would put the wires on these screws. The hot would go on the shorter of the 2 prongs, and these are on the right side as you're looking at it. These are normally a copper, silver, silver's here, copper, bronze here. So, might have confused you there, but I'll go ahead and write it down. On the common side, it's usually a silver screw. On the hot side, it's usually a bronze or copper screw. This screw is usually green. Green will denote that that's the ground. Okay? Silver, bronze, green. Let's bring some power to the receptacle. The power will bring in, representing this power is coming from somewhere. This power could be coming from the panel. If it goes directly to the receptacle from a panel, then that would be a dedicated receptacle. This can also come from another receptacle, a switch box somewhere that's feeding the power over. It could be coming from somewhere else. That's what we need to know here. We'll have other videos that explain how to bring power from other places. So for now, just know that we're bringing power in. Power is usually a black wire in a Romex cable. Then there's a white wire. And the white wire in the Romex cable is usually the common. There will also be a green wire. And that'll be a bare conductor in a Romex wire. Bare conductor, white wire, black wire. Romex wire is a name brand for a wire that is called Romex and it's a non-metallic cable. It's flexible. When you see wires in your house, it'll be like a white wire, a cable, a white cable. It'll have 3 wires in it, white, black, and a bare copper. It's the yellow wire that you see in a house. That'll also have the white, black, and the bare copper in it. And those are Romex name brands typically. There's other brands out there, but I think Romex was first to the game. We usually call it Romex, but it's a non-metallic cable in a plastic. It's a plastic sheathing that contains the 3 conductors inside of it. So we'll represent this circle here as combining the wires so that it's a Romex. You can say that this would be the Romex wire, and then you'd have a white, a bare conductor, and a black inside of a sheathing, which is Romex non-metallic cable. The ground wire, the bare conductor, will go to the ground. The white wire will go to the silver screw. The black wire will go to the copper bronze screw. Okay? When we connect the white wire to the silver screw, this connection is continuing through the receptacle. Internally of the receptacle, this screw is on a little piece of metal, and it's making a connection internally to the long prong on the receptacle. So you have a continuous connection going to the common when you apply the white wire to this screw. On the hot side, when you tie that wire, the black wire, to the screw, there's an internal connection on this piece of metal that goes inside, and it connects to the small prong. And the ground, when you make the connection internally, this is connected to all the metal parts that's on the receptacle. And that's usually called a yoke. So this metal is being connected to this ground screw. So the ground screw and this is basically one continuous electrical point. It's they're all continuous. It's the same electrical point that if you were to check resistance here and here and here, it would ohm out that it's the same piece of metal electrically. This screw internally is connected to the long prong, the silver screw. The long prong and the 2 screws essentially is the same electrical connection, one piece of metal. On the hot side, the same thing's going on. The bronze screw is connected to the small prong, and it's being connected together through a piece of metal, making it the same electrical point. This side is separate from this side. So you can look at this as one piece of metal that's going around on this side, and it's separate from the continuous piece of metal that's going from here to here. On the common side, long prong, silver screw, common side. So these are connected here on this side, here on that side, and then the ground again is connected to the metal parts of the receptacle. As we're sitting right now, the 120 volts that's coming from somewhere, that's what we're powering this with, is 120 volts. there's 120 volts that sits between the hot side and the common side. It's waiting to supply 120 volts somewhere. There's no energy being consumed at this point. It's sitting there waiting to be utilized. So if we want to connect a lamp, we'll use that as an example, a table lamp, we'll draw a little picture. Okay, the circle represents the bulb. This is representing the filament inside the bulb. And these wires will be connected to a plug that you're going to plug into the receptacle. The lamp is standing here, not being used. There's no energy being used. The receptacle is here, ready to give energy. When you want to make the lamp come on, you're needing the lamp to make a light through the filament. Is where that's going to happen, causing the energy to flow. So you say you want to plug it in to get a light going. One of the wires, when you plug it in, will be coming to typically the black wire that's coming off the lamp. When you plug it in, the white wire is also coming over and connecting to the white wire on the lamp. The green wire that comes out will get connected to the green wire that's on the lamp fixture. This is what's happening when you plug it in. Power comes from the black side of the wire of your Romex. Power's coming up the black wire. It connects to the screw. It goes through. You have the plug in here. So when you have the plug, you got a black wire leaving the plug, and that comes to the filament inside the lamp, goes through the filament, comes back on the white wire, which is going to the common, and it comes back to the screw, the silver screw, and it comes back out, and it goes back to the power source. So it's a continuous flow is what's going on. When you have the plug, the hot plug, when you plug it in, it's going to the filament, and then there's a white wire that the power's coming back on. Here's your bulb again. So if this is the hot, that's here. When you plug it in, it leaves on the black wire, goes through the filament, and it comes back on the white wire, the common, which is here. So again, you plug it in, that's the hot prong, power comes in to the screw, it's going on the hot prong, comes out to the filament, and then it comes back on the white wire, and it comes back to the power, where the power comes from. So, let's do another demonstration of maybe what that's looking like. This is a black wire. This is a white wire. And then this is a bare copper. Wire. you have a receptacle. That's what we're kind of demonstrating here. Black wire is bringing power. We'll start over here for a second. There's the receptacle. It's waiting for power. Power's here on the black wire, and you're going to tie it to this screw on the hot side. This is the silver screw, which is the common side. It's coming back. This is the ground wire here. So maybe that helps with the visual, okay? So the power is sitting on the copper side screw, small prong, and the power, and the other side of the power is the white wire, which is common, on the silver screw here. So again, when we take a plug and we plug it in, power is leaving the plug, goes into the filament, and it returns on the white wire common side. So when you make that connection with the plug, power will now start to transfer into the light. Electrons start moving, current starts flowing, and that's why the light comes on, is because it's receiving electrons, which is a current flow, and the resistance that's in the bulb will light and have a light as a result from the current flow. That's something that I'm going to explain at another time, another video, but for right now I'm going to try to keep it real simple so that you can understand what's going on. When we plug that lamp in, the black wire will start generating electron flow from the screw. It goes out the plug onto the black wire that's going internally to the filament, and then it comes out on the white wire that's attached, going back to the common plug, and then it leaves, and then it comes back to where the power started at 120 volts is what we're talking about here. So maybe we can use a different pen that'll show up on the camera here. That current flow is this again. You plug in the light, and that starts transferring electrons. Current will flow to the black screw. It goes out the plug, around the filament, comes back on the common white, and then it goes back to the power source. That's what's happening there. If this was DC power, which we're not really going to demonstrate too much as DC power, that would be a continuous path. DC is direct current. It would be a continuous directional flow in the same direction. So what would happen is, if it was direct current, it would go around and it would continue this path over and over and over. But what we have in our houses and commercial buildings is called alternating current. So what happens is, the power will go like I just showed you and come back. But then it switches. That's why they call it alternating current. And then it takes the same, it goes back this way. So it takes the same, the path of electrons The connection is the same, but it's reversing. It goes over, then it reverses. But what you really only have to know for this particular point that I'm saying is, it's starting out on the power, goes up to the light, through the filament, and it comes back. And then alternating current, it will switch directions, and it does that at 60 hertz. We can talk about that at another time. Okay, so what I also want to introduce to you is what's called parallel circuit. That's how we wire our receptacles in the house or commercial buildings for general purpose receptacles. You don't want to wire it in series. You might think it's in series because you've got something that's sequential. People tend to go, oh, it's sequential, it's series. But that's not what's going on. There was a time whenever Christmas tree lights were wired in series, and they may still have some out there. I can't say they don't have them out there, but Christmas tree lights, when I was young, I remember you put a bunch of bulbs in, and if one bulb went out, it would make the rest of the bulbs go out that's downstream from it. That would have been in series, where if you have the bulbs, if you had 10 bulbs in series and you broke or took the 7th bulb out, then the 8th, 9th, and 10th, 7, 8, 9, and 10 bulbs would not work, and then the other ones would work. That's in series. That's not what we're doing in houses. We're doing them in parallel. And parallel allows, if you break one of those bulbs in the Christmas tree light example, if you break one, you break the 7th bulb, the rest of the bulbs still work. You break the 5th bulb, the rest of the bulbs still work. That's why when you break a bulb or a bulb goes out in your house, whatever, everything else continues to work because we're in parallel. So this is what parallel looks like. Okay, we just added 2 more receptacles to the wall. Let's say that this is a wall. Then we have 3 receptacles on one wall. The black wire will still go to the bronze screw. The white wire will go to the silver screw. The ground wire will go to the green screw and back to the bare copper. Then on this receptacle, the black wire goes to the bronze copper screw, and the white wire will still go to the silver screw. The green wire will still go to the bare copper wire, and that's what's going on in parallel. If we were to plug in, let's say, a vacuum cleaner, we have a plug, we plug it in, the black will be bringing the power on the screw, it goes up to the vacuum cleaner, it comes back on the white wire, and it makes a path back to the source. Now let's say we were to plug in a fan. Little oscillating fan to cool ourselves off when it gets hot in Georgia. You plug it in. When you plug it in, the black wire is bringing power. It goes up to the fan, and it comes back on the common, and it goes back to the power source on the white wire, and then again the ground is here protecting the circuit. Grounding is a whole other topic. For right now, just know, put your ground on the green screw. If we were to take one of these and unplug them, the other two will work. It's just like when you're at home. If you plug a light bulb in and you have your light bulb, the lamp connected, and you have your vacuum cleaner and you're running that, and you have your fan on at the same time, everything's working at once. But if you turn your fan off or unplug your fan and move it, your vacuum cleaner still works and your light still works. Because they're in parallel is why you're able to do that. I'll go over the individual circuit path. We've already did the lamp. I guess we can do it one more time and then we'll go through the three. You plug the lamp in. Power comes from the black wire on this cycle, goes into the bronze screw, the power side hot, comes up through the filament, comes back on the common wire, and then it comes back to the power source. And we already said that it'll go out in that direction on one cycle, and then it reverses and it comes back on the other cycle. But the vacuum cleaner, you plug it in. Power comes from the black wire, goes into the bronze screw, it comes up into the vacuum cleaner, and there's a wire inside, and then it comes back on the white, and it comes back to where the power source is at. So you've got that doing the same thing as what the lamp was doing. Power comes on the bronze screw, travels up to the vacuum cleaner, it comes back on the white wire, which is the common, and it comes back onto the white wire of the common, going back. The fan, you plug the fan in. You got power coming to the bronze screw, it goes up to the fan, and it comes back on the common wire and goes back to the power source. You can remove one of these devices and the other one still works because they're in parallel. The bare copper wire connects to each one of the green screws, and that's providing a grounding system. For you guys that are, or gals, that are installing receptacles on a job site or trying, wanting to demonstrate your knowledge to a contractor so that you might can get a job, these are going to be in boxes. Each one of these receptacles will be in a J-box, junction box. So when you bring your black, white, and common into your box to wire up a receptacle, let's say this was the first one where your wire came. You'll bring your black wire in to your screw on the hot side. You'll bring your white wire in to the common side, and you'll bring your ground wire that's coming into the box on the common side, the ground side screw of your receptacle. Then you've got a wire coming in. Well, you've also got a wire leaving in this demonstration, and in the real world, whenever you bring a wire in, if you want to feed the next receptacle, you've got to bring a wire out. So you bring your wire in, you got a black wire, you got a white wire, and you got a bare copper wire. I just represented that coming into the box. So then you need to take a wire to leave the box. So this, when you leave the box, all you have to do is take the black wire nut it to the other black wire, take the white wire that's leaving the box and then wire nut it to the white wire, and then you'll take your grounds and you'll put them together. So you'll have a black wire tied to this. Now you're going to the next receptacle. Now you're coming into this box, and you come to this receptacle. All you have to do is wire nut this wire. You got the white wire coming in, wire nut that to the white that's leaving. So you wire nutted the black wire to the wire that's coming into the box, leaving the box. The white wire coming into the box, leaving the box, you wire nutted those. And they're going to the next box. The black wire that you wire nutted, you can put a pigtail, which is a third wire, and you can connect it here, and then this wire nut is here. So this is representing a black wire coming in, a black wire leaving, and a black wire that's got to get tied to the hot. So tie those three, the wire coming in, wire going out, and you can make a pigtail that will attach to the hot. White wire coming in, white wire leaving, wire nut those, take another little piece of white wire and tie that to the screw. You can do that here. White wires coming in, white wires leaving, another white wire that's going to the receptacle, wire nut those together. The black wire coming in, the black wire leaving, the black wire that's going to the receptacle, wire nut those together. Black wire leaving, you come in, put it to the receptacle, white wire leaving, put it to the common side of the receptacle, and then the ground, you put on the ground. It's the same thing here with the grounds. Ground coming in, ground leaving, ground here, wire nut them. This ground is coming to here, same thing. Tie all your grounds together and hit the green screw. Tie all your grounds together, hit your green screw. In this particular one, there's only one wire left because you only have one wire coming in, you're not leaving at this point. But this can be continued on for as many receptacles as you need on that wall. And then obviously when I say as many as you need, you have to look out for 15 amps, not to exceed your 15 amp circuit, not to exceed your 20 amp circuit. Another topic for another time, but basically I'm saying you can put as many as you need within reason, and this is how they work, is in parallel. I hope this was helpful. We've got some other videos coming up that will be talking about things like switches and different types of switches. We'll go over some electrical theory as it pertains to residential and commercial. And if you would, I appreciate you hitting the subscribe button, the like button, and look for more coming videos. Thank you for your time.